Okay, Algebra 6.3. This is now combining the things you did in the last two sections. So this equation, 3x minus 7 is less than 8. Again, you can think about it if it was an equal sign there. And so we're going to add 7 first. And so it would be 3x is less than 15. And then you divide by 3. So x is less than 5. Example 2 just looks a little more complicated, but just take it one step at a time, doing the things that you've been doing all year long. Negative 0.6 times x minus 5 is less than or equal to 15. So first thing you're going to need to do is go ahead and expand that negative 6 to what's inside the parentheses. So negative 0.6 times x and negative 0.6 times negative 5, which is going to end up being negative 0.6 plus 3 is less than or equal to 15. Subtract the 3 from both sides and divide by negative 0.6. Well, when we divide by a negative number, remember, we then flip that inequality. So at the very end, we're going to flip the inequality, and it's x is greater than or equal to negative 20. Similar with this one, but this one's interesting because we have x's on both sides. So how would you solve it if it was an equal sign? You're going to subtract the 2x from this side to put it over there. You could subtract the 6x, but it's nice to keep it with positives and not deal with negative numbers. So subtract a 2x over here and add 7 over here, and so that ends up being 4x is greater than 24, and then we divide both sides by 4, so x is greater than 6. Same thing with these, except now we need to expand that 7 into the parentheses, so it becomes 14x minus 21, and then we can, well, if we have 14x and 14x, now we can subtract the 14x's from each other, and 5 is less than negative 21, which is, there are no solutions where 5 is less than negative 21. Therefore, this one is unsolvable. You want to be looking for that on the test. There probably will be one similar to that, and it's really trying to trip you up, but mostly you just need to be focused on doing the steps that you know that you've been doing all the way through. So 12x minus 1 is greater than 6 times 2x minus 1. You're going to expand that parentheses out again, so that ends up being 12x and negative 6. Well, now if we have 12x's on both sides, we're going to subtract the 12x's. So then the 12x's now are gone, and negative 1 is greater than negative 6, which is true. So all solutions, you could put any number in for x. So this, in the first one, there is no number that you could put in for x. In the second one, any number for x actually works. Okay, that is 6.3. Again, do the same sort of things you've been doing, but with an inequality. And then you if you're dividing or multiplying times a negative number, you have to flip the inequality sign. And moving on to 6.4. 6.4 is, now we're going to talk about multiple inequalities, compound inequalities. And that means basically we have an inequality with an and or an or sign. So in the and, it means it has to be both of these things. It has to be it has to be greater than negative 2 and less than 1. So that's how you graph it. Greater than, less than, or equal to 1. So that's where we have the open dot there and the closed dot there. But in the or, it can be either, it can fit either this one or that one. So this one is x is less than negative 1. So we can graph that, and then x is greater than or equal to 0. So you can graph it that way. You're going to graph both of them, and it means x can be either this one or that one. So x could be 1, x could be -2, and so on and so forth. And I would start by graphing one of them. So like start with the -2 is less than x, and so you would do an open dot there at -2, and then you would have it go greater than that, and then but then you have to graph this one. 1 is less than or equal to, or x is less than or equal to 1, so you would graph it there, and it is only going to go between those two numbers because we know that it has to fit both of those. This inequality, -2 is less than x, which is less than 3. So x has to be in between those. It has to be, it's an and. When it's written like that, that means it's it's greater than -2 and it's less than 3. So we can start with -2, we do an open dot there, we start going bigger, and then we know we stop at 3 because it has to be less than 3. It cannot be 3. Now we've got x is less than x is less than 0, or x is greater than 2. So we're going to take the 0 and it's less than that. So we have an open dot and it's going to go down the number line because it's going to be less than 0, and then 2, and we're going to go up the number line because it's going to be greater than 2. A couple of real world problems, and here's this one. 2 is less than x plus 5, which is less than 9. So that's kind of an interesting one because we've got this x plus 5. What do we do with that x plus 5? So we have to, this is called a compound. We can break it into 2. So our first one is 2 is less than x plus 5. So now we're going to subtract 5 from both sides, and it ends up being -3 is less than x. And then we can take this other side, x plus 5 is less than 9, and we break that up and work on that side. We're going to, again, subtract 5 from both sides, and so it's x is less than 4. Well, now we have -3 is less than x, and x is less than 4. So we can graph that out right here because we know it's got to be between -3 and 4, but it cannot include those because it's not less than or equal to. Similar one, -5 is less than or equal to -x minus 3 is less than or equal to 2. So we're going to break it up into 2. -5 is less than or equal to -x minus 3, and then -x minus 3 is less than or equal to 2. We're going to add 3 to both sides, multiply both sides times -1, so we have a positive x, but when we multiply it times -1, we're going to have to flip it. So now we have, so first you add 3, so that ends up being -2 is less than or equal to -x, and then it's 2 is greater than or equal to x. And then the same thing over here. We're going to add 3, so that becomes 5, but then we have to make it negative, and so x is greater than or equal to -5. So now we've got -5. Basically, x is going to be between -5 and 2. A little confusing how they did all that, but just think of it as start with this side and then do that side, and it has to fit both of those. And just remember, when you do the negative number, you have to flip the inequality. This one is 2x plus 3 is less than 9, or 3x minus 6 is greater than 12. And now we're doing or, so you're going to do both of them. You're going to graph each one, and they're going to be graphed on the same number line. So subtract 3, divide by 2, and then this one is add 6, divide by 3. Once you do that, it's x is less than 3 and x is greater than 6. And so you can graph that on the number line right there pretty easily. And that's pretty much it for 6.4. So good luck.